It's a blue team. We are a voice system, and this is our root Locus design for Engineering 229 UTC. My name is Lynn and Kevin O'Brien and Mike Albert is also in my group. And basically today I'll be going over an outline, give you a system overview description of the SSOC, step response, FOPD theory with model theory to compare to that, those results, sign response and parameters, both the experimental and the model, with Bodie plots and those results, and then move on to the root Locus parameters, plots and results, and look at conclusion. This is a schematic of our system. We have a transmitter and two controllers along with our motor and the generator, which goes to a load of light bulbs, just as before. And this is a block diagram of our manipulated input, which is the percent motor power put into the system, and our controlled output, which comes out in volts, in the generated voltage. This is our SSOC. Again, we have where it's most linear slope is from a range of 67 to 80% input, and again, the red you have our output operating range, and the blue you have our input operating range. I guess I can use this in my hand. Right here, this is just showing you with the step response how we get our delta M, our delta C, and our dead time, or tau. Again, here you can see how steep the voltage system with the slope is, and fitting a linear line with it to get our dead time and our tau. Here, it's a steady state operating curve, and where we did the step inputs, we had a range of 65 to 70%, then from 65 to 75%, 65 to 80%. Here we have an average gain, and as you can see in the step-up response, as the smaller the input, the larger our gain was, and as the input range increased, the lower the gain decreased, which was interesting, and I'll come back to that later on in the presentation. Here the average dead time, we have some fluctuation in between the input, the step ranges, again starting out huge and then it decreased and then went back up. This could be due to human error and graphical from eyeballing from the graph. Here average tau, in the step ups we have a smaller input range. As it increases, the average tau decreases. Here is for FOPD model. These are equations that use for the manipulated input and then the controlled output. These are the FOPDT model parameters for a step size from 65 to 80% in both the up and down directions. Of course, we have our time constant, our tau, our gain of 5 volts, and then in the step down 2.1, which I will show the graph. And here is where we did the model results for the range of 65 to 80%. And as you can see, where the yellow covers up the blue is our step, so it accurately agrees. And here we configure the model, which is the, I don't know how to seafoam color looking thing with the pink, and we configured it as close as we can to compare the model with the experimental. And again, with the step down, same process. And here is where in the block diagram where we compared the experimental model, the experiment with the model in both the up and down direction. As you can see, the smaller ranges, the model and experiment were fairly similar for average gain. And then with 65 to 80% fairly similar, but right here in the middle from 65 to 70, we had a great difference. Average dead time again showing the same thing between the experimental model in both up and down directions. And then also with the average tau, same thing, experimental model in both up, fairly similar in lower range, and then the model seemed to decrease in the wider ranges with the experimental. Here's frequency parameters that we'll be looking at. AR amplitude ratio, of course, the T0 is the dead time, T is period, phase angle, where you get your dead time over your period times 360, and your change in output and change in input. Here are using the steady state operating curve showing the baseline inputs that we used for the frequency response. In the 65 to 70% range, we did 67.5%. 65 to 75%, had a baseline input at 72.5%. And then 65 to 80%, we had a baseline input at 75%. This right here is just basically showing, given frequency of 1.9, finding the period from peak to peak on the input value, and then also determining three dead times from peak to peak and the output voltage to get a student T later. Here is basically showing the Lejeune plot with the delta C over delta M for a range of 70 to 80% input. Again, comparing with the frequency model. Here's frequency parameters for Bodie that we used is the KCU's ultimate controller gain, FU ultimate frequency, ARU is ultimate amplitude ratio, K is a system gain. And this I want to show is, of course, closed loop negative feedback controller, where RFS is your reference point, EFS is the error function, and we have KC, which is our controller gain, and then we have what I showed you earlier, which is added on with the input, the manipulated input function, our system, and then the controlled output function. Right here is a Bodie plot, which is the Bodie plot for a baseline input of 72.5, and from this, of course, we did the same technique of from 180 and going up, and we were able to find our FU and then also find our three parameters that we'll use later, which is the ultimate controller gain, tau, and T naught, 2.78, 0.58, and 92. Here is the Bodie plot of that previous graph, and this right here is comparing experimental with the model. You see the experimental is blue, the model is red, and we figure it till this line fits as close as possible in order to get these three parameters. And here is baseline Bodie plot for baseline input at 75%. Again, same process, finding the tau, T naught, KCU, and also our FU value. Here's Bodie plot comparing experimental with the model and receiving the three parameters for our gain, time constant, and tau. And right here you see a huge drop between the experimental and the model, and a lot of reasons this is just the way it's zoomed in. This is a bar chart comparing the frequency results between the 72.5% baseline input and the 75% baseline input. We would have a third one, but we had a team member drop out and we just weren't able to complete it in time. Here is comparing the gain, the ultimate frequency, the ultimate controller gain, and the amplitude ratio. Now you see the gains are fairly similar, which is a good thing. And then when you get to FU and all the KCUs are a little bit different, but not too bad. And this right here, getting into the root locus parameters, we went back to the three baseline inputs that I showed you before in the SSOC, 67.5%, 72.5%, 75%. And from the Bodie plots that gave us the three parameters, we